For a temporary 60 amp service running to an experimental machine in an industrial setting, several factors need to be considered to ensure safety and code compliance. The installation involves a 480 volts breaker panel, a 60 amp fuse disconnect, and a 220-foot run, potentially tie-wrapped to overhead structures. The National Electrical Code, Section 590, addresses temporary installations. NEC Section 590 stipulates that NM or NMC type cable is typically required for hard usage industrial applications. However, there are exceptions and suitable alternatives like tray cable. Tray cable is designed for installation in cable trays or enclosed raceways. It features a thicker jacket offering more resistance to damage than NN cable. PVC jacketed tray cable is appropriate for dry, indoor locations. It's a cost-effective choice but offers less protection against moisture. Exposed run direct burial cable has a durable jacket for underground installation, providing better protection against the elements but at a higher cost. Considering a temporary installation for 6 months, a 220-foot overhead run, and limited exposure to moisture, PVC jacketed tray cable can be a suitable option. It provides adequate protection without unnecessary expense. When using PVC jacketed tray cable, ensure it's properly supported and protected from sharp edges. If the cable is exposed to direct sunlight, use a UV-resistant jacket. Always obtain the necessary permits from local electrical authorities before starting the installation. Now, let's delve into more detail regarding the NEC requirements, cable types, and installation best practices. Understanding the specific requirements outlined in NEC Section 590 is crucial. This section covers temporary electrical power and lighting installations, which are defined as those used for a limited time. Common examples include construction sites, holiday lighting, and, in your case, running power to experimental equipment for a defined period. The NEC prioritizes safety in these temporary setups, and that is why it specifies that NM or NMC cable is required for hard usage industrial applications. NM cable, or non-metallic sheath cable, is commonly used in residential wiring. NMC cable, or non-metallic sheath cable with corrosion resistance, offers additional protection in damp environments. However, the code recognizes that alternative cable types can be suitable when installed correctly and used within their intended applications. This is where tray cable comes into play. Tray cable, often abbreviated as TC, is designed specifically for use in cable trays and raceways. It consists of multiple conductors insulated with a thermoplastic or thermosting material, all encased within a common jacket. The jacket material can vary, with PVC being a common and cost-effective choice for indoor applications. Tray cable's construction provides several benefits. Firstly, it offers increased mechanical protection compared to NM or NMC cable, making it less susceptible to damage from abrasion, impact, or crushing. Secondly, it's often rated for higher temperatures, allowing for greater ampacity in certain installations. Thirdly, tray cable can be easier to install in long runs and complex cable management systems. PVC jacketed tray cable is an excellent choice for your application because it balances cost, protection, and ease of installation. However, it is important to verify that the specific tray cable you select is suitable for the voltage and current requirements of your 60 amp 480 volt circuit. Check the cable's ampacity rating to ensure that it can safely handle the 60 amps load. You must also confirm that the cable's voltage rating is at least 600 volts, exceeding your 480 volts requirement. If the cable will be installed outdoors or in a damp environment, choose a tray cable with a jacket that is specifically rated for wet locations. In situations with direct sunlight exposure, ultraviolet or UV-resistant jackets are crucial to prevent degradation of the cable jacket over time. Now, let's compare PVC jacketed tray cable to exposed run direct burial cable. Exposed run direct burial cable, often referred to as USE or RHW, is designed for direct burial in the ground without the need for a conduit. It has a very robust jacket that provides excellent protection against moisture, abrasion, and chemical exposure. While this type of cable offers superior protection, it is typically more expensive than PVC jacketed tray cable. Given that the installation is temporary, indoors, and overhead, the added protection of direct burial cable might be an overkill. For your specific application, PVC jacketed tray cable is more than adequate for protecting the circuit. Now let's dive into the installation considerations. Firstly, proper support is critical. Since you plan to tie-wrap the cable to the roof structure or sprinkler piping, ensure that you use appropriate cable ties that are rated for the weight and size of the cable. The cable ties should be spaced according to the manufacturer's recommendations, typically every few feet, to prevent sagging and strain on the cable. Avoid over-tightening the cable ties, as this could damage the cable jacket. Also, do not use metal ties, as they can damage the wire over time. Secondly, protect the cable from sharp edges. When running the cable along the roof structure or sprinkler piping, be mindful of any sharp edges or protrusions that could damage the cable jacket. Use appropriate chafing tape or protective sleeves to cushion the cable and prevent abrasion. Thirdly, ensure proper termination. Terminate the tray cable at both ends, the 480 volts breaker panel and the 60 amp fuse disconnect, using appropriate connectors and fittings. Follow the manufacturer's instructions for terminating the cable and ensure that all connections are tight and secure. Use a torque wrench to tighten the connectors to the specified torque value to prevent loose connections and overheating. Now, let's address permits and inspections. Before commencing the installation, obtain the necessary permits from your local electrical authority. The permitting process ensures that the installation complies with all applicable codes and regulations. The electrical inspector may review the installation plans and conduct an on-site inspection to verify that the work is performed safely and correctly. Be prepared to provide the inspector with documentation such as cable specifications, installation instructions, and circuit diagrams. Remember to also confirm the following considerations. Firstly, confirm ampacity. Double-check the ampacity of the selected tray cable to ensure it meets or exceeds the 60 amp requirement of the circuit. Consult the NEC ampacity tables for the appropriate conductor size based on the cable type, installation temperature rating, and installation conditions. Secondly, grounding. Ensure that the grounding conductor within the tray cable is properly sized and connected to the grounding system at both ends of the circuit. Proper grounding is essential for safety and helps to prevent electrical shock hazards. Thirdly, overcurrent protection. Verify that the 60 amp breaker in the 480 volts panel and the fuses in the 60 amp disconnect provide adequate overcurrent protection for the circuit. The overcurrent protection devices should be sized according to the ampacity of the conductors and the requirements of the NEC. Now let's talk about safety precautions. Always de-energize the 480 volts breaker panel before working on the electrical system. Use appropriate lockout-tagout procedures to prevent accidental re-energizing of the circuit. Wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Work in a well-lit and ventilated area. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation. Now let's delve deeper into the specific NEC articles that may apply to your temporary installation. In addition to NEC Section 590, consider the following articles. NEC Section 300.11, Securing and Supporting Wiring. This article requires that all wiring be securely supported and fastened in place. Pay close attention to the spacing requirements for cable ties and ensure that the cable is not subject to excessive strain or abrasion. NEC Section 310.15, Ampacity of Conductors. This article provides detailed information on how to determine the ampacity of conductors based on various factors such as insulation type, ambient temperature, and number of conductors in a raceway or cable. Consult this article to ensure that the selected tray cable is properly sized for the 60 amp load. NEC Section 400, Flexible Cords and Cables. While you are using tray cable rather than flexible cords, this article provides valuable information on the proper use and installation of cables in various applications. Review this article to ensure that the installation practices align with the NEC requirements. Now let's explore some additional best practices for your temporary installation. Firstly, label all electrical equipment. Clearly label the 480 volts breaker panel, the 60 amp disconnect, and the tray cable with appropriate voltage and amperage ratings. This will help to prevent confusion and ensure that only qualified personnel work on the equipment. Secondly, document the installation. Keep a detailed record of the installation, including cable specifications, circuit diagrams, permit information, and inspection reports. This documentation will be valuable for future reference and maintenance. Thirdly, inspect the installation regularly. Periodically inspect the installation for any signs of damage, wear, or deterioration. Check the cable ties, connectors, and overcurrent protection devices. Address any issues promptly to prevent electrical hazards. Now let's talk about troubleshooting. If you encounter any problems with the temporary electrical service, such as tripping breakers, blown fuses, or equipment malfunctions, follow a systematic troubleshooting approach. Firstly, identify the problem. Determine the specific symptoms of the problem, such as the location of the tripping breaker or the type of equipment malfunction. Secondly, isolate the problem. Use a process of elimination to isolate the source of the problem. Disconnect equipment one at a time to see if the problem goes away. Thirdly, repair the problem. Once you have identified the source of the problem, take appropriate steps to repair it. This may involve replacing a faulty breaker, tightening a loose connection, or repairing damaged cable. If you are not comfortable troubleshooting the electrical problems, hire a qualified electrician to perform the work. Remember to prioritize safety at all times. Always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment and follow lockout-tagout procedures. By following these guidelines, you can ensure that your temporary 60 amp service is installed safely and correctly, providing reliable power for your experimental machine. Before concluding, let's summarize the key points. PVC jacketed tray cable is a suitable option for a temporary, indoor, overhead 60 amp service. Ensure proper support protection from sharp edges and termination. Obtain necessary permits and inspections. Verify ampacity, grounding, and overcurrent protection. Follow all safety precautions. Consult relevant NEC articles. Label equipment, document the installation, and inspect regularly. And remember, if you are not comfortable, hire a qualified electrician. The goal is a safe and code-compliant temporary electrical service. Remember to always prioritize safety when working with electricity and consult with a qualified electrician if you have any concerns.